39 engineering parameters, 40 inventive principles, 4 separation principles, 76 standards, 8 methodology patterns, and systems evolve towards ideality or ideal final result. So today, we won't be touching all of this. We just will be touching the 39 and 40, because this is actually the basis of this, and this is what we found first before we found the rest. So and it'll be interesting to find out also how we want to explore this 39 and 40, which is inside your note. So what happens is that if you have a problem, without trace, usually we use our own knowledge, try and error, Google this, Yahoo that, then become the solution. May work, may not work, but we don't want to be in the statistics of 1 is to 3,000. So what happens is that Auxiliary rate is formula. So if you have a problem, compare yourself with typically problem previously solved. In this case, we are using 39 parameters, and those things will show you what typical solutions are. It won't tell you immediately your answer. Cannot be, because it's quite impossible for him to come up with okay, I have a problem, blah blah blah, this is your answer. Cannot. So he says these are possible answers. Okay, so in this case, we're using the positive principle, and then he gives you your solution. The tagline of this is saying that someone somewhere has already solved a problem like yours. So if you look into the industry of what you call it, waste treatment plants and whatnot, it's already existing in the world today. So not to worry. If you have a problem, somebody else already have a problem like that and probably solve it for you. Okay, this is the 39 parameters. You want really to go into each and every one of them. It's there in your notes. The explanation is there. What is weight? But if you notice, all these things are actually anything that describes everything. You have weight, you have length, you have area, you have volume. Quite straightforward. Nothing magical about it. Not rocket science. Stress, shape, things like that. Right? So altogether 39. And apart from this 39, they also come up with 40 inventive principles. So these inventive principles are those things that tell you where to look at to find your solution. Again, I think not necessarily to go through everyone. This is all inside your notes. Perhaps the best way to discover them is to try out some exercises. Okay. So remember earlier when we say breakthrough solution. A breakthrough solution is a result of overcoming the contradiction. So the whole idea about the 39 and 40 is to find out what are the contradictions. Right? So if you want to reduce costs, what's stopping you? If you want to increase efficiency, what's stopping you? So that is a contradiction. Right? If you want to increase the strength, but your weight is stopping you, right? So how do you resolve this? So this is what they say, overcoming contradiction. So in most cases, we usually accept compromise or trade-off, but this is often not necessary. And powerful solutions are the ones that don't accept trade-off, and we should always look for the. So the 39 and 40 actually helps you to do that. So what happens is that this is the matrix. Your 39 parameters will be your X and Y. So what you want to do is here along the Y-axis. What is stopping you is along the X. Okay, so if you cross-reference, let's say if you want to improve the weight, but what's stopping you is the length, then it gives you what to look at in terms of the inventive principle. Here is 10, 1, 29, 35. So 10 is the most important thing to look at. And then if you think 10 is not good, you look at 1. 1 not good, you look at 29. So it's also a bit of guessing work, but then as you do more and more, you find that certain things always is similar. So certain problems, you always find that there are certain connection to some inventive principle quite similar. This one is inside your notes, but it's a bit long-winded, so I summarize very well. So you take a look at this problem. it's not actually a problem lah, but they're trying to actually come out with new things all the time. So they say right now the bicycle seat they cater to certain kind of people. So you must be that size before it becomes comfortable. So if you're a bit overweight, maybe it's not so comfortable, or you get pain and things like that. So they say come up with a comfortable bicycle seat. Right? So your contradiction here is that a bicycle seat is both wide, which is the wider it is, the more comfortable it is, but doesn't impede your leg movement. Right? So the reason why it's nice and streamlined, you find that those Tour de France, Tour de la Cavi, they sit very slim or not, because they want to give the riders free movement, but that is very uncomfortable. You always find that the cyclists, they always have to wear the pants with the padding inside lah. So without the padding, it will make it uncomfortable. So here you refer to the parameters. What you want to improve, they don't have width there, but they have length, so you can use length. And what's stopping is the shape. Okay. So if you cross-reference inside the matrix, the length and the shape, it gives you this inventive principle 13, 14, 15, and 7. They didn't say this is the answer. They said look at it, try to look at this. So if you go back to what it is, it refers to 13 is the other way around. Maybe sounds a bit Greek lah, but never mind. 14 is the virtual increase, 15 dynamic parts, and 7 is the law. So here also, if you're new to trees, you may be thinking, what is it? You don't have to worry. So all that is actually explained inside the table. So here they say, let's take a look at 13, the other way around. Okay? So make it simple. Usually the one at the top is the one that you should be looking into, and then it is a degree of lesser importance. So, and then the last will be a step down, maybe something which you don't need to use at all. Right? So referring to the appropriate suggestion given in the reference, we are looking at 13, the other way around. So the other way around, if you look at the tables, it gives you this meaning. So it says make movable parts fixed and fixed parts movable. And for the dynamic part, divide an object into some parts. So you want to see if an object is rigid or inflexible, make it movable. So if you look back at this design, it's very rigid. So and we want to actually increase the width, but we don't want to obstruct the cyclist movement. So they came out, this is actually a product from ABS Sport. I'm not sure, but you can Google it. They came out with this seat. So it's wide, it's comfortable, but as your leg goes down, it follows your leg. And then if you get tired, you can shape it this way as well. So I've not tried it lah, but maybe it makes sense lah. But again, they are saying whether this will be accepted or not. Usually, in most cases, when people look at it, it looks very strange lah. Jadi mungkin I don't think I'll buy it. But then, if you look at the problem, it solves the problem actually. Only thing that this one looks very aerodynamic lah, so people see very nice.